At least you're honest.
If you don't record it, then that's gonna be the night we meet.
Right.
Yeah.
Okay, I'm recording. So here we go. This is 40 degrees. That angle right there. Then this and this are equal, and so is this. And you are trying to find angle 1, correct?
Yeah.
Alrighty, well, let's see what we got. We got all these equal side thingies, right? So this side and this side are equal, so what does that tell you? It tells you the angles opposite are equal. Why? Because of the Isosceles triangle theorem. So that means if this is 40, then what's this? That's 40, okay. Now let's take a look at this. This side and this side are equal, right? So that means that this angle and this angle are equal to each other. Agreed? All right, so let's see. Well, look, these two sides are exactly the same, aren't they? And these two, I don't know if I can say that. No, let's not go that direction. Let's do this. Let's find this angle. What's this angle going to be right here? Right, because that's 80, so that's going to be 100. And what's this?
80.
This is 80. These two are exactly the same, aren't they? So what do they have to add up to be? They have to add up to be what? To 100, right? Because 180 is 180, right? And then you take half of them because they're both exactly the same. So that is what? 50. Wasn't that fun? These two, because this side and this side are equal to each other. And they told us this was 40. They told us this was 40. So if these two sides are equal to each other, then the angles opposite those two sides are equal because of the Isosceles triangle theorem says that. Okay, so this has to be 40. That has to be 40. We find this one, right? By knowing this and this, they're supplementary, right? That's 80. You know, these are the same right here because of the same reason, right? Because this and this. No. Because look, this could have been angled a little bit differently, right? Just because these two are the same as these two. And I was thinking of that myself, actually, but then I talked myself out of it. Yeah, but look, I could have done this. I could have, look, I could have done like this, right? And still, this would have been equal to this. I could have made this length the same as this, but I could have angled it differently, couldn't I? Right? You don't know. I mean, yeah, it looks like a straight line right here, but I don't know. I don't know how to explain that. But just because this side and this side is equal to this side and this side doesn't mean the opposite angles would be equal to each other, right? Would you agree? Like if I did that? Right. So you have to go by, I did a terrible job explaining that, but yeah, this has to be 50. They can't be 40, right? Because look, if that's 80, there's no way that can be 40 and this can be 40, right? Because that would only give you 160 degrees in that triangle. You can't have 160, you got to have 180. So they have to be 50. Got it? Okay. Remember, that theorem doesn't say any triangle with this length, the angle opposite that length is always going to be 40 degrees, right? It just says in one triangle, if I have two equal sides, the opposite angles are going to be equal to each other. Make sense? Okay. Let's do the other 11. Probably kind of the same thing, right? All right, here we go. This is 80 degrees, right? Let's. What do you want to do? Let's find these. You want to find these down here?
Yeah. Yeah, it's easy. Aren't all the points just 80 degrees? No.
No. So if this is 80, what's this going to be right here? These add up to 100, right? So it's the same one as we just finished doing. So that's 50 and 50. Agreed? What about this angle right here? Is there any way we can find that angle right there?
Yes.
And this is where the parallel lines come into play. Because look, I got parallel lines cut by this transversal right here, right? Let's just extend it out just so you see it a little bit better. Do you see that? Everybody with me on that? So look, if this is 50, look what it does. It connects this parallel line to this transversal. This connects this parallel line to the transversal. So this has to be 50. So you had to know that thing about the parallel lines, didn't you? Let's put these back where they belong. Okay. You're right, because look, these two sides are equal to each other, aren't they? So these two angles opposite the equal sides must be equal to each other as well. So if this is 50, then guess what this is? That's 50, and that's all you had to do. Okay? It's kind of fun, isn't it? 12, all right. On that page? All righty. 2D, same one.
know how you could do it. You could grab all
Probably goes more like that.
18x minus 8 plus 6x minus 4 equals.
I don't know. I got to look at it. Still not perfect, but that's okay. So this side and this side are equal, right? And this angle right here is 18x minus 8. That's a weird 8, isn't it? Why can't I do 8s? What's my problem? Yes, we did. 2 days. All right, here we go. Let's see. What can we do here? Let's use the isosceles triangle theorem. I got two equal sides, so that means the opposite angles have to be equal. So this is 6x plus 4. So what's this one right here? This one's 6x plus 4. What do all three of those angles do? They add up to 180. So, yep. Yep, you add all three of them up, set them equal to 180, bang, you're done.
So basically,
I don't have to do that for you, do
all
I?
the isosceles triangles and look for the isosceles triangles.
That's the first thing I would do. If I saw isosceles triangle, the first thing I'm thinking is the opposite angles are equal. Yep.
Because that's pretty much what I've seen in every single problem.
On 2D, 5 and 6. All right, let's find them. All right, let me draw that picture.
Did you do 3 too? I really need to see 3. I don't understand.
We'll keep the. I tell you what, I'll keep the picture white. No, I might. All right, here we go. I'm doing 4, 5, and 6 on D. So that looks like that. Kind of looks like that. Kind of looks like that. Right? And that one looks like that. All right. Let's do these in different colors. This is what we're trying to solve for, right? Well, we're actually solving for 1, 2, and 3. Well, 1's easy. But we need to find it anyway, though. So let's just put that. That's 70 degrees. Okay, I'll put that in there. That's angle 2. This angle up here is 80 degrees. And this is angle 3. And these are parallel. Alrighty. And we're trying to find 1, 2, and 3, correct? 1's easy. What's 1? 110. Yeah. 180 minus 70. That was simple. Okay, now watch this. Look. Parallel lines. Parallel lines cut by transversal, right? What are parallel lines cut by transversal? Look, if that's our 70, isn't it? See, there's your parallel line, there's your parallel line. And what's this? That's 70 as well, because they're what? Corresponding angles. Okay, so that's 70 degrees right there. Once I get that, that's 150. So what's that? It's just 30. That was the hardest part, just understanding. It wasn't that hard to do, because I just said it's equal to the same angle. But it was, it took a little thought to understand parallel lines cut by transversal, corresponding angles, all that good stuff. Okay, and then that was easy after that. We good? Let's do one of the distance formula ones, like number 3. We're on 2D. Let's just stick with 2D. Is that all right? Okay. Try this color. All right. It says find the measure of the size of the triangle, the vertices of triangle EFG. Triangle EFG. And here are the vertices of the triangle. It's 1, 4, and F is 5, 1, and G is 2, negative 3. And we have to decide what kind of triangle is it, right? So we got 3 choices by its sides. We got it could be equilateral, it could be isosceles, or it could be no sides are equal, which is scalene. All right, so we got to find the 3 sides. We don't even have to draw this thing out, do we? What are our 3 sides? Well, EF is one side, right? What's another one? FG is another one, and then GE or EG, I'll call it EG. Is that right? Is the third one. Everybody understand that? Yeah. Okay, so we just have to find the distance formula 3 times, right? And then just compare the sides. That's all we have to do. So EF. So 1, 4, and 5, 1. So the distance formula is square root. And then you do this thing. Looks like Pythagorean theorem, doesn't it? Yep. And so what do we do to these numbers in here? We subtract them, right? We subtract them. So subtract the x's, subtract the y's. Doesn't matter what order we subtract them in. Doesn't make any difference. So let's do the x's first. What's easiest? 5 minus 1, which is 4. We'll just do that in our head, can't we? All right, let's do the y's with E and F. 4 and 1, subtract them. That's a 3. Doesn't matter which order you subtract them in. So let's see what we get. That's 16. We can do this in our head, can't we? 16 and 9 is 25. 16 and 9 is 25, right? Square root of 25 is 5. All right, so that's, I should have put, let's not put D, let's put EF. Is that right? So EF is 5. We good? Let's do FG. All right, so once you know the distance formula and how to do it, it's actually pretty quick. It looks like really long and crazy, but it's not that bad. F and G, these bottom two right here. Subtract the x's. What do you get? 3. Subtract the y's. It's negative. You could do it two ways. You could go 1 minus negative 3. Minus negative is plus. 1 plus 3 is 4. That's 9. That's 16. 9 and 16 is 25, and that equals 5. So far, we got an isosceles triangle. Now, we don't know what the third one is. It could be 5 as well. If it was 5, it'd be an equilateral triangle. Okay? If it's not 5, then it's isosceles, right? So let's just find out what it is. So EG. So EG is the first and the third one. So we do this thing again. And we subtract. So you could go 1 minus 2 or 2 minus 1, which is 1. Let's do this one. 4 minus negative 3. What's minus a negative? It's plus. So it's 4 plus 3, which is 7. Right off the bat, I can see that's not going to equal, but let's just find out what the number is. That's 1. That's 49. So that's what? 50. Square root of 50, obviously, is not the same thing as square root of 25, correct? And you can just leave it like that if you wanted to. All right? It's 5 square root of 2. Can you do that in your head? 25 times 2. Square root of 25 is 5. Square root of 2. So look at these sides right here. You've got a 5, and a 5 square root of 2. What kind of triangle?
Isosceles.
It's isosceles. And that's what you want to do. All that work just to say it's isosceles, right?
And how many are we going to have on the test?
Like that?
Yeah.
I don't know. I wouldn't think any more than one. I wouldn't think. I don't have it in front of me, so I'm not positive. But let's do a proof. Let's do that one where you guys were asking about. Which one was that?
It was on
10.
Are there going to be proofs?
It was
on the
10.
test?
Yes, I said that earlier. Yep. I think you have like 3 of them on there. But they're all relatively short and easy. They're not real complicated ones. No, you got to do them all. You got to do it all. But it's pretty straightforward. I mean, you write down a given, and you may have to find one little thing, and then say the triangles are congruent, or after you say the triangle's congruent, say the corresponding parts are equal because CPCTC. You know, it's not going to be real complicated. So let's take number 10 and pretend that's our proof, okay? Because that's probably something that I could give you. Now, they don't actually ask you in this particular question to do a proof, do they? It is. I like that. Especially on the black, it looks cool.
Well, it looks kind of cool.
Let me scooch it down.
Yeah, it's not perfect.
That's all right. Let's see what we got. We got B, C, D, and A. And let's make this a little thicker. All right, and what do they tell you? They do give you a little bit of given, don't they? It says it's an isosceles triangle with BD being perpendicular to AC. So if it says it's isosceles triangle, let's say they gave you that BC is equal to BA. All right, that would make it isosceles, wouldn't it? Okay, say it's congruent, and they also say that BD, line segment BD, is perpendicular to AC. And what are you basically trying to prove? Trying to prove that, yeah, let's just say we're trying to prove they're congruent to each other. Okay, we'll make it real basic. So we're trying to prove that triangle BDA is congruent to triangle BDC. Everybody good with that? All right, so statements, reasons. There we go. All right, so let's take a look. Let's mark the thing up, right? That's the first thing I do. So it is my favorite part. BC and BA are equal to each other. Bang, bang, right there. All right. BD is perpendicular to AC. So BD, AC is perpendicular. So that means if it's perpendicular, there's a right angle. Okay. That's all they tell you. Now we got to figure something out. Well, there's actually a couple things we could figure out. Isn't there? I got 2 sides equal to each other. So it's an isosceles triangle, right? So what have we been talking about all day today? Isosceles triangle theorem, which would say what and what? That's right. A and C are equal to each other, right? Now, that's not because of the given, but what would be my reason for that? Isosceles triangle theorem, okay? So is that enough to prove the triangle's congruent? Actually, it is. Okay, because look. Yeah, because if this is perpendicular, this is a right angle, and all right angles are equal to each other, right? So there you go. And look what I got. I got angle, angle, side. You could say that, first of all, you would say it's a right angle. If they say it's perpendicular, what you do is say, in your step after that, is to say that angle BDC and angle BDA are right angles. And why is that? It's because of definition of perpendicular lines. Because definition of perpendicular lines say two lines that form a right angle. Right? That's what the definition says. So I could say they're both right angles. But then after that, we can say that they're actually equal to each other. We could say that BDC, angle BDC, is equal to or congruent to angle BDA. Why is that? Because all right angles are, I said it earlier, well, yeah, we know they're 90 degrees, but all right angles are equal to each other. They're congruent, right? They're congruent. And there's a little statement, I don't know if it's a theorem or corollary or postulate or what it is, but there's something in there that says that all right angles are equal. All right angles are congruent. Okay, and that would be your reason for that. So let's go ahead and do this. First thing I would do, I would go with, we're going to go angle, angle, side, aren't we? So let's do the perpendicular stuff first. Is that all right? Just to go angle, angle, then side, right? Actually, we may have to go a little bit out of order. Let's do the sides first. I changed my mind. Watch. BC is equal to BA. Why? It's given. Well, it said it's isosceles, so I said, let's just say that they're equal to each other. All right. So now we could do the angle thing, right? So let's say it. Angle A is equal to angle C, and it's because of the isosceles, I'll shorthand it, isosceles triangle theorem. Everybody with me on that? Okay, so what is this? This is one of our sides. It might not go exactly in order here, but that's okay. That's one of our sides. This is what? One of our angles. Now, what else do we want to find? Those right there, right? What do we have to say first, though? First of all, we have to determine that they're perpendicular, correct? So let's say that. So BD is perpendicular to AC. Why is that true? It's given, right? They told us. Now, if they're perpendicular, what must be true about those two angles? They're what? They're both right angles, okay? That's what we're going to say. We're going to say that angle BDC and angle BDA, oops, BDA, got a little ahead of myself, sorry. I'm running out of time, that's why I'm trying to go quick, are what? Right angles. And why is that true? Because of the definition of what? Perpendicular lines. Yeah, it's not a midpoint. It's definition of perpendicular lines, okay? That's what it says. Look up perpendicular lines. It says two lines that form a right angle. That's what definition of perpendicular lines says. Now, since we have them both right angles, what's true about any right angles? They're equal to each other. That's right. So angle BDC is equal to BDA. Okay, why? Because all right angles are equal. Good. And it's a theorem or something. You don't even have to know what it is. But all right angles are equal. What did I just do right there? I found another angle, didn't I? Yeah. Now, we don't have side angle, angle. What do we call it? Angle, angle, side. So now I can say that my triangle, BDA, is congruent to triangle, BDC. And that's because of angle, angle, side. Okay? Now, look, I could have asked you to do this. I could have asked you to prove that angle, let's say CBD, is equal to DBA. How would I do that? No, I wouldn't even have to do that. I mean, you could have used reflexive property in here, but that wouldn't have helped you. But look, if I've already proven the triangle's congruent, didn't I? I just finished doing it, right? So this is my only part that I really don't know, that are equal to each other. Now, once I've proven my triangle's congruent, then I can say CBD, help me out, it's angle CBD, and what was the other one? ABC, is that what it was? I don't know. It was ABD. ABD. Okay, now I could say they're equal to each other. Why are they equal to each other? Look what I did. I proved my triangle's congruent first. Then I can say any other matching up parts or congruent corresponding parts. The CPCTC. Okay? The proofs on the test will not be any more difficult than that right there. Okay? That'll be about as hard as it gets.